Hello, welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for chemistry for the year 2018. This is the concluding part, okay, where we look at the next 20 questions or the last 20 questions for the year. If you're new to the channel, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam and modular quizzes for free. The radioisotope used in industrial radiography for the rapid checking of faults in welds and casting is cobalt. Okay, cobalt 60. Cobalt 60 is used in radiography for the rapid checking of faults for checking faults in welds and casting. The carbon 14, they use it in carbon dating. Okay, in carbon dating to determine the is used to determine the lifespan of an artifact. Okay, the lifespan of an artifact. Phosphorus 32 is used in treatment. The same thing with iodine 131. It is used in the treatment of thyroid cancer. Beryllium and aluminum have similar properties because they have diagonal relationship. Okay, they are positioned diagonal to each other in the periodic table. Both of them, they have the tendency to form covalent compounds. Okay, because they have equal electronegativity. Both of them form complexes and they may dissolve in strong alkaline solutions to form complex. Their oxides are amphoteric, meaning it can act as a base and as an acid. Both of them are also passive with acid. They did not undergo reaction readily with acid due to the formation of a protective film, okay, a protective film or covering of the oxide, which will inhibit any further reaction with the acid. In the equation above, the equilibrium constant is given by, so this will be it. It is. So how do we get the equation of reaction there? So I'm going to explain this. Okay, now let's say we are given a chemical reaction like this. Alright, let's say we are given a chemical reaction like this here. AP plus BP giving CR plus DS. Okay, I want to jump straight to the solution here. So this is going to become, we are going to start with the product side. Okay, the product side. The equilibrium constant K is going to be equal to this R raised to power the number of mole of R, which is C, and multiply by this X here raised to power the number of mole of X, which is D. So you have R raised to power C, concentration of R raised to power C, alright, the concentration of F raised to power D, over, then we now take the product, the reactant side as well, P raised to power A plus Q raised to power B. So that's how it goes. So for this reaction here, what we simply do is, for this one we are going to start with the product. We have G raised to power P times H raised to power Q over E raised to power M times what? F raised to power N, and that's it. Next, the reactions above represented, the reactions represented by the equations above demonstrate D. It demonstrates the reducing property of ammonia. Okay, the reducing property of ammonia. As you can see in all of these reactions here, ammonia has been oxidized to nitrogen gas. Okay, meaning in the sense that the hydrogen in it has been removed, and the removal of hydrogen is oxidation. Okay, the substance that is oxidized in a chemical reaction is the reducing agent. So the ammonia here is a reducing agent. Okay, it is a reducing agent. It reduced the other substances it was reacting with to become oxidized itself. The salt that reacts with dilute hydrochloric acid to produce a pungent smelling gas, which decolorizes acidified purple potassium tetraoxomanganate 7 solution is. That salt, okay, is this sodium triazosulfate. Okay, it is sodium triazosulfate. Now, what you observe here, okay, is that this sodium triazosulfate reacts with hydrochloric acid to form sodium chloride water and sodium sulfur 4 oxide. Okay, it is this sulfur 4 oxide that will now that will bleach a moistened colored flour. Okay, a moistened colored flour. It will also bleach a solution, okay, acidified solution of purple potassium tetraazomanganate. Manganate. Okay, it will decolorize it. It will change its color from this purple color to colorless. It will bleach its color. All right, so it is sodium it is sulfur 4 oxide that gives this reaction here, and that can be produced from reacting this salt here, okay, with hydrochloric acid. The refreshing and characteristic taste of soda water and other soft drink is as a result of the presence in them of soda water is produced by dissolving carbon 4 oxide, okay, carbon 4 oxide in water. Which of the following are mixtures? Petroleum is a mixture of various hydrocarbons, okay, petroleum or crude oil. Rubber lactate is also a mixture, okay, it's a mixture. The vulcanized solution is also a mixture obtained from dissolving ethanol and rubber, ethanol, and some other substances. Why this carbon 2 sulfide is a compound, okay, it's a compound of carbon and sulfur. So you have I and I. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. A balanced chemical equation obeys the law of it will obey the law of conservation of mass, in that the sum of the atomic masses of the reactants will be equal to the sum of the atomic masses of the product. Okay, so if you see in this reaction now, for example, you have 2 hydrogen on this side, 2 hydrogen here, 1 oxygen, 1 oxygen, 1 chlorine, 1 chlorine, 1 sodium, 1 sodium. So if you add up the atomic mass of all the elements here, it will be equal to the sum of the atomic masses of all the elements here. Alright, so that obeys the law of conservation of mass, that matter is neither created nor destroyed. Okay, that law in quotes, matter is neither created nor destroyed. So you can see that in this reaction, no new element has been created here. Okay, no new element has been created. Now this is the case with regular reactions, but in nuclear reaction new elements may be created. However, the sum of the mass of the reactant will be equal to the sum of the masses of the a given amount of gas occupies 10 dm cube at 4 atmosphere and 273 degrees Celsius. The number of moles of the gas present is, we have the molar volume of the gas at STB to be 22.4 dm cube. So in solving this question, we are going to be using the ideal gas equation, where we have PV to be equal to nRT. P the pressure, V the volume, N is the number of moles, this R here is the molar gas constant, and this capital T here is the temperature. Okay, so in the question we have the volume here as 10 dm cube. How do you know that it is the volume? By looking at, if you look at the unit dm cube, that's the unit of volume. Alright, then again, even from there it says occupies. When we say volume, volume is the space that a substance or an object occupies. Okay, so when they say occupies this, it means that the volume is 10.0 dm cube. You have the pressure to be 4 atmosphere. You can also tell that from the units. Then the pressure, the temperature is 273 degrees Celsius. We will have to convert this to Kelvin. Okay, converting this to Kelvin, you are going to add 273 to it, so you have 256 Kelvin. Always endeavor to convert your temperature, okay, to Kelvin when you are dealing with, when you are using gas laws. Okay, when you are using the gas laws or the ideal gas equation. Now the molar gas constant is a constant, and it is 8.314, or it is 0.03205 liter atmo per mole per Kelvin. And in this question, this is the value that we are using. Okay, the liter is your dm cube. So since we have this in dm cube, we are using this this for our molar gas constant. Now from here, it is the number of mole that I want to find. They said the number of mole of the gas present is, so that's what we have to find. So to make number of mole the subject, we are going to divide both sides by RT. So I'm going to have N to be equal to PV over RT. We will then substitute what we have from the question. So pressure 4 times the volume, which is 10, over the molar gas constant times the temperature. By the time you multiply this is 40 divided by what you get here, you'll be getting 0.8929, and that is approximately 0.89 mole. According to Charles' law, the volume of a gas becomes 0 at, it will become 0 at minus 273 degree Celsius. Why? Because this 273 degrees Celsius, if you convert it to Kelvin, so convert it to Kelvin, you are going to add 273, meaning you are going to have minus 273 plus 273, and that will be equal to 0 Kelvin. Now in Charles' law, the volume varies directly as what? Temperature. Okay, at a constant pressure, of course. The volume of the gas varies directly as the temperature. So if what that means is that as the volume is increasing, the temperature is increasing, or we say as the volume is decreasing, the temperature is decreasing. Now if the volume now decreases until it becomes 0, then automatically the temperature will also become 0. It's also reduced until it becomes 0. A substance that is used as a ripening agent for fruit is, that is ethene or ethylene. Ethene or ethylene is used in the ripening, artificial ripening of fruits. Next, the sulfide which is insoluble in dilute hydrochloric acid is, that is the sulfide of copper. Okay, copper sulfide and lead sulfide are insoluble in dilute solutions of hydrochloric acid. What is the pH of 0.001 mole per dm cube solution of the sodium hydroxide? So the pOH, okay, the pOH plus the pH is equal to 14 for a given substance. The sum of its pOH and its pH is equal to 14. We say the pH is minus the log of the hydrogen ion concentration, and the concentration here is 0.001. So you say this is minus log, okay, 0.001. Now 0.001, that is 10 raised to the power minus 3. 10 raised to the power minus 3 means 1 over 10 raised to the power 3, and 10 raised to the power 3 is 1000. That is 1 over 1000, which will give you, this is 0.001 here. Now using one of our laws of logarithm, we can bring this minus 3 to this side here. If we bring it to this side, we are going to have minus 3 log 10. Log 10 is equal to 1. Minus times minus 3 will give us 3. So that's the pH. We will then calculate the pOH. We say the pOH plus the pH is equal to 14. If I want to get pOH, I'll just bring this pH to this side here. This is plus pH. When it comes here, it will become minus pH. So the pOH of the substance here will be 14 minus its pH. So that will be equal to 14 minus 3, which is equal to 11.
You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below.
What type of bonding is in this complex here? That is coordinate bond. Okay, complexes consist of coordinate bond between the atoms. Which of the following is an example of a chemical change? So changes are of two types: physical change and chemical change. When we say a chemical change, which is what this question is about, a chemical change is a change in which no new substance is formed, while a physical change, is a chemical change is a change in which new substances are formed. Okay, new substances that are different from the original substances are formed, while a physical change is a type of change in which no new substance is formed. Now if you look at dissolution of water, of salt in water, if you dissolve salt in water, there is no new substance that is formed. In this case, it's just salt water that you'll be getting, still the salt and the water. If you melt ice, okay, The ice is originally water. If you melt it, you just go from ice, from the solid form to the liquid form. Water is still water, whether as an ice or as the liquid water, it is still the same thing. So there is no new substance that is formed there. Also, if you separate a mixture by distillation, the mixtures already they retain their physical properties. Okay, let's say a mixture of petrol and oil. Do you understand? Or a mixture of miscible liquids, which is what we usually use distillation for. Those liquids that are in that mixture that are separated by distillation, they originally they still maintain their physical properties and chemical properties. The only thing is just that they are just mixed together, just like the petroleums I have in crude oil. Those hydrocarbons, they are just mixed together, but they still maintain their property. Okay, but the rusting of iron is an example of a chemical change, in that the rust, that iron is going to change. It will become oxidized. Okay, it will become oxidized. So that iron now, that rusted iron, or that iron rust, will now contain oxides of that iron. Okay, so you are going to have iron 2 oxide and iron 3 oxide. So this is new substances that are different from the original iron that you have. At what temperature must a gas at 273 Kelvin be heated in order to double both its volume and pressure? Alright, this is a question on gas law. Okay, we'll be using our general gas equation here. Okay, where we have P1 V1 over T1 is equal to P2 V2 over T2. Now we know the initial volume, the initial temperature of the gas. Okay, this gas is originally at 273 Kelvin. That's the initial temperature. We now want to know that what must be its temperature. Okay, what must be its temperature in order for the new pressure, to be 2 times its original pressure. The new pressure is P2. Okay, so at what temperature is P2 going to become 2 times P1, and V2 is going to become 2 times V1? That is, the new volume become 2 times the original volume. So when we substitute all of this into this equation, we have P1 V1 over 273, the initial temperature, is equal to 2P2, because 2P1 rather, that is the new pressure P2, the new pressure here P2 is now 2P1, that is 2 times the original pressure. So 2P1 times the new volume, which is 2 times the original volume, 2V1. Now this P2 and V1 here will cancel on both sides of the equation. So here we are going to be left with 1. Okay, so you have 1 left here over 273 is equal to this 2 here times 2. This is 4 over T2. To get the value of T2, we then cross multiply. So when we cross multiply, 1 times T2 is T2. Then we are going to have 4 times 273, and that will be 1092. 1092. Okay, so this temperature must increase. The temperature of this gas that is currently at 273 Kelvin must increase to 1092 Kelvin in order for the pressure and the volume to double. According to the kinetic theory, an increase in temperature causes the kinetic energy of the particle to cause the average kinetic energy of the particles to increase, because those particles will gain more energy. Okay, they will gain more energy, so they'll be able to move at faster speed on the average. A decrease will do the reverse of that. A decrease in temperature will cause the kinetic energy of the particle, the average kinetic energy of the particle, to. An element used in the production of matches is sulfur. Okay, sulfur is used in the production of matches. They also use it to produce gunpowder, antiseptic, vulcanizer solution, etc. Which of the following gases may not be dried with concentrated sulfuric acid? Ammonia. Okay, because ammonia is a base. Okay, so if you dry it with concentrated sulfuric acid, if you dry it with an acid, then an undesirable acid-base reaction is going to occur. Okay, so we don't use sulfuric acid to dry ammonia gas, but we can use like calcium oxide. Calcium oxide can be used. Alright, final questions here. Consecutive members of an alkane homologous series differ by. Generally, for any family of organic compound, the difference between the consecutive member is a methylene group, that is CH2. It is a methylene group. For example, the first member of the alkane is CH4, that is methane. The next member is ethane, which is C2H6. If you look at the difference between C2H6 and CH4, it is what? CH2. That is, if you add CH2 to this now, you'll be getting C2 H6. If I want to know the next member after ethane, all I need to do is to add CH2 to this. If I add CH2 to this, I'm going to have C3H8. That will be propane. If I want to know the next member, I'll add CH2 again to it. If I add CH2 to C3H8, I'll be getting C4H10. That will be butane, like that. So the consecutive members of an alkane homologous series, and generally any other family of organic compound, like the alkane, the alkyne, the alkanols, the alkanic acid, the amides, the ketones, and all of that, the difference between them is a methylene group, the CH2.
Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Scholar Edu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.